Muted.
.org video that came out in 2013. It was a fun video that just showcased why you would want to do computer science and showed all the fun that the computer scientists were having. And that became the founding part of the reason why code.org exists. After the video, everybody said, "This is really great. We all want to do computer science. How do we do this?" And he realized at the time that he wasn't an educator. He really had no idea. He just wanted everybody to decide that this was something fun that they should do. So he said, "Well, I want to do something really big." So the first venture was YouTube, and that went viral, and that was big. And he says, "I want to do something really big. What can I do?" And he said, "How about if everybody just tried to do an hour of coding? And how about if we just make something really simple? Because if they do this, they'll realize that coding is really not that hard, and unless they try it, they won't know." So then he started the Hour of Code campaign. So for those of you that were able to go on or have been able to go on code.org now, and you see the Frozen videos or the Star Wars modules, these are what we use, and they're used all over the world to show about how easy it is to do coding. They're little modules that don't require that you have any type of account or anything, and so people have done them worldwide. The sad part for us at the beginning is that they've been more popular in other countries than they have in the U.S. And so it is our continued mission to make sure that every student in America learns how to do computer science. And so that's why everything that we have is entirely free. So after the Hour of Code happened, we realized that we wanted to do something a little bit more. So following that became the curriculum that we have. So we have a K-5 curriculum. It's courses 1 through 4, and they are designed and they look very similar to what you will see with when you do Frozen or anything. So hopefully some of you can get online and look around a little bit to see the course 1, 2, 3, and 4. And this is what we are doing. And what we do in our workshops is we teach teachers or anybody that wants to work with students how to use this curriculum. And really the students get on, they do it, and they have a great time. It's a lot of fun, and it's very, very easy to do. So one of the reasons why I would like you all to try it is then you'll understand how easy it is. Or if you have a student and have them go play on it, because it's not really challenging, and it's very fun, and that's the exciting part of this. And so this is an example of trying to explain how our videos work. So everything is open source. It's online curriculum. When we teach the curriculum, we do not teach one language in particular, but we teach general computer science concepts. The 4 courses that you will see today if you go online are for grades K through 5. Everyone also has self-guided videos, which are very fun to have students look at. They've got Bill Gates, Mark Zuckerberg, but they also have a lot of young women and people of very diverse backgrounds to be able to showcase how this is kind of fun and exciting to do. The teacher dashboard. So if you were able to sign up for an account, you can sign up either as a student or if you can sign up as a teacher. If you sign up as a teacher, you're able to see the lesson plans, and you're also able to see some additional resources that allow you to see how the students are doing. And on the website that you have seen, if you go to stempv.education, if you go to the top where it says code, that's an example of what my workshops currently look like. there's additional resources that you can go on and use there. One at the bottom is called the teacher dashboard, and that shows you how to set up a teacher dashboard so that you can see how the students are doing. And again, this is something that we go over in detail in a 7-hour workshop. The 7-hour workshops are very helpful because you get a chance to be around other people and see how they work and see what's going on in the community. And so that's one reason to do that. A strong advantage of teaching computer science is that when learning computer science, you actually learn a lot of math skills, English skills, language arts skills, and science skills. So you learn a lot of the STEM, the foundational STEM skills. So if you go to code.org or you go to some of the links that I gave you, you will see this Find a Workshop area. And one of the founding principles of code.org is that everything will be free. And so when you go to these workshops, there is actually no cost for you to go and attend to learn how to do this, and you don't have to have any prior knowledge. And the only request is that you figure out a way to work with students. So that could be that you're volunteering, or in your community areas, perhaps you can have an after-school event where you have all the students come and be able to participate in a way. When you go to the workshop, you get a swag bag of fun stuff and all kinds of fun materials. This is an example of what you would get. So you get the bag, you get the curriculum, and you get some course materials to use with the students. So at the end of the workshop, you get that. And you also get the opportunity to learn from an instructor and really learn from peers in the area. So this is one of my my favorite pages because I really like it. So when you're talking to students or even young people for any reason, generally you have to give them a set of instructions. One of the foundational concepts in computer science are called conditional statements. And this is an example of a conditional statement. And really no computer program runs without a conditional statement. And so for this one, it's saying, you know, if you have an early reader, use course 1, and if not, use course 2 or course 3. So and then course 3. So the reason why course 1 and course 2 are identical in many ways, and course 1 is designed for students that can't read. So there's a lot more pictures, and in course 2, you start to have more reading. So an advantage of all of our curriculum, because as I mentioned before, it is done worldwide. All our code.org curriculum is done in different languages. I believe we have 50 different languages. So if any of you are currently on code.org on any of the pages and you go, you will notice in the bottom left-hand corner you can change the language. So this is an advantage for a student that perhaps doesn't speak English as a first language, and it's also an advantage for students who are trying to learn a different language. So that's kind of a fun feature that you can use. So, so I recommend for you to try this because it is a lot of fun. So course 1 is an easy way to get started. Again, course 2 is a duplication of that. And then course 3, they get more and more challenging. And by course 4, if you complete course 4, you'll have a really basic understanding of computer science. And everything is done in a game type fashion. So, so it becomes very fun and engaging. The advantage of this is as the students are learning computational thinking. So prior to, so there's a period where, you know, when I was younger, and so I'm 50, And when I was a young student, and I was in high school, computers came out, and I decided that I went to go to learn on an Apple computer, and I was told that I had to type my my research paper on this computer. And so I went to go type my research paper on the computer, and then at the end I didn't really understand what was going on, and so I didn't understand why I had to type because I didn't really know how to type, and I was really frustrated by the whole experience. And I came back the next week, and they said, open up your saved documents. So when I went back, I realized I didn't save my document, and I was really mad because I thought it was a waste of time, and I didn't want to do it, and I decided that I would never have anything ever to do with computers. So I made the decision at that point, as a very wise young lady, that I would never use a computer. So I went through my undergraduate, and I was able to find a computer. I became a botany major, and I was able to successfully graduate without a computer science course. And then later I realized that that wasn't very smart because everybody was learning and using computer science courses, and I went back and I took some programming classes and began to do a lot more programming in my career. But what I found in doing these workshops, and as I mentioned, I've taught 350 different educators, is that for about a decade or 2 decades, we stopped teaching any computer science in schools. So in the period where I was learning and making my wise decision, people were learning. They were learning BASIC, and they were learning Pascal, and after that, they started to learn Microsoft Word and Microsoft Excel. And then there became a time where the computer labs were not even being used for Microsoft Word and Microsoft Excel. They were being used more and more for standardized testing. So what happened is you had a period of a decade or more where we didn't have any children that were learning any type of computer science. So the challenge became, was when they went off to college, is they didn't know any computer science. So if you have a student that decided that they wanted to learn any programming, most of those students were ones that had maybe played computer games. But when they got to college and they were doing the computer games, they had actually never written one line of code. So what was happening is the university instructors said, oh, we don't know what to do. How are we going to teach them? So they would create they started using programs that were similar to Scratch, which is similar to what you're using right now, which is the object-based programming. So if you get on code.org and start to use any of these modules, you'll be using the same thing that the computer science young students were using when they were going to college. And so imagine if we are able to have all of our students now learn at the kindergarten, first, second grade, the same information that they were learning in college, how much more powerful they can be. Because computer science is very much like a language. Once you understand the computational thinking behind it, it's much easier to switch from one language to another. So you might learn Java or Python or whatever. But it's all based on these same thinking practices. And the advantage of the very young students is if they are able to learn this computational thinking when they're young, when they move into these next developmental levels, it's very easy for them to go from language to language to language, which is why it's so important and so valuable to have them use this type of curriculum. So as I mentioned, so our founder, he has put his time, money, and all of his life into creating this code.org company. And a foundation of our organization is that every student will be able to access this without any additional cost. So sometimes you might find that there is a program out there that you can use or in a school or after-school activity, but it only works with one platform. So it maybe only work for a Mac, might only work for a PC, my Chromebooks or whatever. So one of our foundational requirements is that everything that we create will work on every platform. That means that this also works on smartphones. So if you have young students, young residents that want to learn how to do this, they can actually do this basic computer programming on any tablet, but even as small as a smartphone. So that's kind of a foundational principle that we have. So many of you might not have been computer programmers growing up, and really that's okay. So and actually that's great, because that means there's more to learn. One thing that we teach in our workshops is that it's very important to understand, believe, and embrace the concept that you're not going to get it right. So most programmers, if you ever get a chance to pull a programmer aside and you ask a programmer, when they write their code, do they expect it to work? Their answer most likely will be no. And this is kind of a good thing, because when the students a lot of times are in school, they go to school and they take a class and either they get an A or they get it right or they get it wrong. And sometimes if they get it wrong, they think they're not good and they edit and they give up, and then that's the end of it. They don't want to do it anymore. But if you help students understand that it's good to not get it, that it's expected that it's not going to happen the first time, and keep trying, and understand that it might not work the first time, but keep working at it. That is the most important thing. So in our workshops, we teach a lot that we do these unplugged activities. So the unplugged activities which come in the curriculum are designed to be activities that do not require a computer at all. And each of these are teaching that concept that it's not going to work. We also have in these unplugged activities where we might give instructions to the students that are not clear, and they are purposely not clear. So the students can get together and they can try to figure out the answer themselves. And a lot of times in schools, and I work with fabulous educators all the time, and they are always trying to make this simple for the students. But what we try to do in this environment is to not make it simple for the students. Make the students kind of, and what I talk about is embrace the struggle. Get them to the point where they're uncomfortable with this and they don't quite get it, but then they can have that conversation with their peers to try to figure out what the answer is. And this could be as simple as writing an algorithm, which is the same as writing a recipe, which is the same as writing a set of instructions, and maybe have the two students in one area write two different instructions. And one of the unplugged activities that we use a lot is like writing a game with cards and having one side of the group write a game and the other write a game, and then switch and have the others play it, and then they might realize that maybe they weren't that clear. Because really that's what you have to understand in programming, is how to be clear and have your instructions be clear. But this is also important in life, and being clear in other aspects of their schooling. So if they learn to be clear in programming, then they're more likely to be clear when they're maybe doing their math. Maybe that helps them realize that you can't skip a step because you have to go step by step. Or when they're writing a paper, that they understand that it makes more sense to the reader if you explain all the steps along the way. So even though computer science seems like it's something different, it really relates to their lives. It also relates a lot to logical thinking, which is not something that we've been teaching as much in the schools, but is very important for students in understanding, how to view the world. So technology today affects every field. So there was a time where you could say, I don't want to study computers like I did. Or you could say, okay, I'm going to be an auto mechanic. I don't have to have anything to do with computers. Well, that's not the case anymore. Or I'm going to go be a farmer. I'm not going to need to understand computers anymore. And that's not the case anymore. Or I'm going to go work in manufacturing. I don't need to do computers anymore. And that, again, is not true. So more and more technology is in every field. So the number of students that are currently studying computer science is extremely small. We've made some progress, but if you look at the number of jobs that are out there, these are the jobs that have the highest salaries, and we have the fewest number of students going into this field. This is a fabulous opportunity for students. It's the great equalizer. If students have an understanding of how computer science works, how programming works, they can do very, very well very easily. Understanding computational thinking teaches problem-solving skills that, again, is important in every job. So even though a student might not decide that they're going to be a computer programmer, they're going to need that skill in every job that they learn. So logical thinking, the process-oriented, it's important for everything that they can do. So I like this graph because it's kind of interesting. If you look at the years, so if you look at 2003 and say to 2013, and we started our code.org in 2013. If you look at this and you think about what happened in that period of time, you think about, have we had any increase in technology in that period? And generally the answer is yes. But did we have any increase in students learning computer science in that period? And that is no. So we're really happy that since 2013 and even 2012, these numbers have doubled. But if you look at that number, that's 50,000. So that's 50,000 students taking AP Computer Science. The number of students that take AP Biology runs about 2 million. So it's very, very small. Again, we're trying to make this grow, and that's a part of what we're doing. So this number is actually 32 now. So this means that if a student takes a computer science class, that class will help count for them to get a high school diploma. So up until in 2013, there were only 12 states that allowed a class. So this means if they take a computer science class, it's only an elective in those remaining states. So some states will count it for math, some will count it for science, and some will count it for foreign language. We're currently in the state of Virginia, and it's counted as a foreign language. So the goal is to make this 50 states and really widen that acceptance of computer science as a foundational skill. So our vision is every school, every student will have the opportunity. So many states are currently adopting programs. Virginia is one of them, where every student will take some type of computer science, and this computational thinking will be embedded in their entire K-12 career. And again, this isn't every state or every area, and so everything that anybody can do in your area makes a huge difference. So these are some of the skill sets that you get from doing computational thinking. And again, they're important in everything that people do and are trying to learn in school. So I like to have this out here to kind of explain how this computer science relates to STEM. So if we think about STEM as 4 thinking skills, we kind of come up with the different ways of thinking about. So when you're thinking about science, to be a scientist, you get good at asking questions. An engineer learns the engineering design process. The engineering design process is valuable because it teaches how to solve a problem with a limited amount of time, money, and resources. This is something that's being brought, when you hear STEM being brought into the curriculum, a lot of times it's including this engineering concept, which in life is very important, because when a student graduates from high school, they will constantly have problems, including how to deal with their own life, because they have to solve a problem, how to live with a certain amount, a limited amount of time, money, and resources, which is why you see a lot of STEM, like building projects, because that's important to how you kind of see the world. And technology is this, the computational thinking is this logical process, very foundational in helping you understand how everything thinks. And then with math, the number theory, patterns. So these 4 principles and how they work together is very important. So with Code.org, we teach the computational thinking skills, which become the foundation to the programming languages. So you might hear the terms JavaScript, Python, HTML, or you might also hear blockly or object-based programming. So again, if you've had a chance to go on Code.org and you're moving around these statements, these if statements, these else statements, these go statements, that's a visual programming. The advantage of doing visual programming, and the advantage of reason why these colleges were starting off with the visual programming, is because it's much easier to learn the actual computational thinking without having to worry about, you might type a period or a semicolon or a letter wrong. And so that's how those work together, and that's the advantage of this. So our curriculum, again, is block-based, and our hour of code is always block-based. This last year, however, we had more and more of our students and our teachers requesting a little bit more programming. So if you get a chance to ever go see the Star Wars curriculum, we actually have 2 options. So for the Star Wars, they can either do the block-based or they can do the JavaScript. So originally we weren't going to really focus on any programming language, but then as we've kind of matured and with more requests, we've decided that the programming language that we will be teaching is JavaScript, and that's also because it works mostly with web-based programming. It's the easiest to do. So a strategy for teaching computer science is take frequent breaks, work in teams, and we love this thing about not to be a know-it-all. And that relates to this, one of these foundational principles that we teach in Code.org is the concept of pair programming. So in pair programming, you actually have 2 students that work together on one computer. And the fun part of that is they learn to collaborate, they learn to work together, but they also learn different ways of communicating and hearing. So you might have to where one student is talking and said, here, move the mouse this way, move the mouse that way, and then the other person is doing it. And that process, they work together. They also start to learn that not everybody hears things or sees things or solves a problem the same way. This is really apparent to programmers because if you try to go in and look at somebody else's code, you'll easily see that they have had the same question, the same problem a lot of times, and they go about it a completely different way. The advantage of pair programming and working in groups is that students understand that there's more than one way to solve a problem, and that can be very valuable. And that there's also, it's important to ask for other people to share in ideas, and especially as they're young and they're growing and they start to learn to work together. So this is a module that we have online. So through the code.org curriculum, if you have a group that's working together and they're in, when you set it up to be a class, you can actually have the two students share the data and be together as they're working together, and it's kind of a fun thing to do. Again, it's much easier to see when you actually come to a workshop, which I hope you will do. And again, my email again was at the beginning and it will be at the end. You're welcome to reach out to me if you have any questions about how to do it. And my email is angle@pd.code.org. So this is an example of our unplugged activities. What we would do is talk about what a loop is and how you would do a loop. And this is a fun activity that we show the students, so the students would, and you can do this with music, where you would do clapping, and then you could see how you do the clapping, and you can see it in a different way, and you can see it in a different way. And so there's that transition between seeing instructions in 3 different ways and gradually going into the concept of understanding how programming works. So this is what a teacher dashboard is. So once you get, if you sign up, you have to sign up for a teacher account to be able to see this. But you can see the students' accounts. You can see your own. So you'll be able to see everything that the students do. There's also lesson plans and resources that you can use, and we have a pretty robust online community that you can use. There are, again, this is where you find the professional development resources, and you can request speakers to come to your area as well. So how to get started. So in the first week of December every year, we have the Hour of Code campaign. So this coincides with Computer Science Week. This is a fun way for you to get people in your area excited about it, even in the school, you're partnering with schools in the area, or even doing them in your own communities, and just having students come in and say, hey, just do an hour of code, and you can have them do the Frozen or Minecraft or Star Wars, and every year we'll have something different. And that's a fun way just to kind of generate that first level of interest. And if they get their own account, they can go further and further in using the curriculum and develop that level of interest and excitement. You can also do a coding camp. Again, we have through this curriculum, which is again all free, you have enough resources, and I've spoken to multiple people who have started their own coding camps just by using the free code.org curriculum, and it's fun, and the kids are excited, and they want to come back, and they want to do more and more and more. You can also share this with educators in your community, let them know how to sign up and come to these workshops, and that's how that works. So on my stempd.education /energy, there's places to get started. I will keep that up for a while for you if you have any, if you'd like to use this as an ongoing resource. And I want to bring back a little bit to the energy literacy. Again, my other position is with the Department of Energy. This is a great curriculum and resources that talks about how the importance of energy. Energy obviously relates to computer science. Without energy, we wouldn't have computers. And we talk in this about all the different ways of understanding the natural laws, earth systems, biological processes, but also understanding fundamentally how energy relates in our world with political and societal influences. So we have this as a resource. You're welcome to reach out to us and we can send you our energy literacy document. It's free and it's kind of fun and gives you a great background for how to get started with energy literacy. So that is what I have. Does anybody have any questions? So we have a chat section, and I'm happy to answer any questions that you might have about code.org. Any thoughts, questions?
And we could also unmute your line so that you can talk to Laura directly. I see some people have raised their hands, so if you don't want to type out your question, you could also do that, and we'll call on you to see if you would prefer to ask your question to the group.
Oh, I see. What month is the hour of the code? The hour code is in December. So it's the first week of December every year.
Okay, I see that Christina Castanidis has her hand up. So I'm going to unmute her. Christina, do you have any questions? All right, I guess maybe she put her hand up by accident. I see.
There's one more question. There's another question, actually, if you go in there. Or it was asking how they access the free energy literacy document.
Can you send the link? It's under Clarissa, can you get to your email to send the link to get to the energy literacy email? Because you can send us an email and we'll send you a document. We also have an online document that you can get to.
Do you want to go ahead and type that in the chat box for everyone as well? Here, let me. Hold on.
Can you get to that?
Hold on 1 second.
So if you go to energy.gov/education, we have an education website and we have a teach and learn site that has information. But if you go to education, it's on there. But we can send you a direct link, so you can download it. But you can also send us an email, and we can send the full document to you, the booklet, and we could also send several of them if you want to share them with educators in your area.
There's also another question from Diego Oros. Is there any grants you are recommending regarding coding for nonprofits?
So there's a lot of, there's more and more resources out there for coding. So the advantage of the code.org curriculum is it doesn't cost you any money to use it. So for you, really, it's the technology. And sometimes you can reach out to community partners that might be able to donate. So if you have like Microsoft or even if you have a high-tech company in the area, that might be able, you might be able to use something like that. Now, do you know if there's anything through HUD, Bernita?
Not for coding specifically. However, we also have the Connect Home initiative, and so that is geared towards public housing authorities and public housing residents, and the goal is to narrow the digital divide by providing families with school-aged children who live in HUD-assisted homes free or accessible broadband access. So that would be the first step to then be able to take advantage of the resources on code.org. And in addition to the internet access Connect Home is also providing digital literacy programs and, in some cases, free or low-cost electronic devices. So those who might need a computer, if you are a Connect Home community, the PHA is engaged with their local broadband provider, and they're working on getting that to their residents. And if you're not in a Connect Home community, there is an email address, connecthome@hud.gov, and you can reach out there and find out how to take advantage of that resource.
And again, all the code.org curriculum is free, and there are additional, so at the, in the resource section, there are additional curriculum resources that are provided for free that we recommend, like Scratch. And we have, so the ones that I've showcased today is the elementary curriculum. We're developing a middle school curriculum, and then we also recommend different ones that you can do for high school. There's programs like through edX that will teach kind of an advanced level of computer science. My favorite one there is the Intro to Computer Science taught by Harvard, which is the CS50. It's a really in-depth course that any student can take, and it's free. It's the #1 course at Yale, meaning that all the Yale students are following along with all the Harvard students through this really free online class that anybody in the world can do. So that's edx.org, and if you also Google CS50, you can pull that up. The advantage is that they're small little short snippets that will give you information. Say you want to understand binary or algorithms or something where you can watch these short little videos that will help you understand an individual concept. So even though you might be working with younger students, this is a fabulous resource that you can use.
And I also want to remind everyone that in addition to the curriculum and code.org itself being free, the workshops are free also. And you don't need to be a teacher in a public school to go. You could be anyone involved in after school or programs for children. So I went to the last one Laura had here in the DC area. And prior to that, I had no knowledge of code. So it's very accessible no matter what level you are. You get fabulous resources and can become a coder yourself. And it's really a lot easier than you think it is. So Laura, how would you find a free workshop in your region?
Through I sent on my stempd.education/energy, there is a link to directly go to register for a workshop, but you can also go just on code.org and search sign up for a workshop there. And you're also welcome to email me, and again my email through code.org is angle, A-N-G-L-E, @pd.code.org if you have any questions now or in the future, any way that I can help you. So yeah, I want to thank you. I'm going to hand it over to Bernita for a second to close, but again, if you have any questions for me in the future, I'm happy, and now I'm able, for all of you that signed up, I'm actually able to see what you do. So I do hope you sign up so I can see all your fabulous progress, because I can see the stats, which would be the same thing that you can see for your students. So when you sign them up into classes, you can do that. If you have any questions about how to do that, you can go to workshop, or you can also click on that top tab that says code, and you'll see actually everything that I teach in my workshops with some of the links to the teacher dashboard as to how to do that. So again, thank you so much for the opportunity, and I look forward to hearing how you guys are doing.
Thank you so much, Laura. And I want to thank everyone who attended for logging on today and spending this time with us for our Energies Everywhere webinar series. For those of you who may not know, we have this series on the third Thursday of every month, and we would like to invite you back for the webinar in September. The theme, our presenter in September will be a nonprofit organization called First Book, And their goal is to get books into the homes of low-income families, and they have amazing resources that we're looking forward to sharing with our housing authorities. So thank you. If there are any, since there are no more questions, we're going to wrap it up a few minutes early. Just thank you again for coming, and we hope to see you all next month at the next webinar series.